Welcome back to Henge Maths. This is a walkthrough video for the Edexcel A Level Maths paper from June 2018. This is pure paper 1. So this is a 2-hour paper, and this was the first of 3 papers, and they're all 100 marks. This was the very first paper for the new A Level spec, so when it changed from modular, the old C1, C2, etc., to the new linear format for the A Level. The grade boundaries are below, so you can see that percentage wise you needed to get roughly 76% for an A star and roughly 23% on it across each 3 papers to pass with a grade E. Because this was the very first from the new A level, I think a lot of students found it a bit difficult, and sort of teachers were getting used to the new system and the new format, so maybe those grade boundaries are a little bit lower. So there are 14 questions in total, 100 marks, so let's get stuck into the June 2018 pure paper 1 from Edexcel. Question 1. Given that theta is small and is measured in radians, use the small angle approximations to find an approximate value of 1 subtract cos 4 theta, all divided by 2 theta sine 3 theta. So let's remind ourselves of the small angle approximations. So the idea here is that when theta is small, as theta approaches 0, sine theta is approximately equal to theta, cos theta is approximately equal to 1 minus theta squared over 2, and tan theta is approximately equal to theta. These are all in the formula book, so you need to find those or just remember them, but it's in the formula book, so that's nice. So I'm going to write this down separately. So cos 4 theta will be approximately equal to, so if we use this second identity, 1 subtract, now theta in this case is 4 theta, so I'm going to put that in brackets, 4 theta squared divided by 2, and so that's going to be simplified to, so 4 theta squared is 16 theta squared, so divided by 2, so we're going to get 1 minus 8 theta squared. Now sine 3 theta will be approximately equal to 3 theta, so sine theta will be approximately equal to theta, and this is all when theta is small, so it's when theta tends to 0, which is what they've allowed us to do. So we put this into our formula, so it's going to become 1 subtract 1 minus 8 theta squared, all divided by 2 theta will remain the same, multiplied by 3 theta. So we're going to end up with, the 1's are going to cancel out, so 1 subtract 1 will cancel out, negative, negative, so we're going to get positive 8 theta squared, divided by 2 times 3, theta, theta, 6 theta squared. So your thetas will cancel out, and so the approximate value will be 4 over 3. That's our final answer for question 1. Question 2. A curve C has equation y equals x squared subtract 2x subtract 24 root x. It wants us first of all to find dy by dx and d2y by dx squared, so the second derivative. We also then need to verify that it has a stationary point, so verify, which means you can just sub numbers in, and determine the nature of the stationary point. So this is all differentiation. So first of all, I'm just going to rewrite it. So y equals x squared subtract 2x subtract 24x to the power of a half. So part A. So we differentiate this. So x squared will differentiate to 2x. Negative 2x will differentiate to negative 2 and multiply by the power, so we're going to get negative 12x. Now subtract 1 from a half, get to the power of negative half. Now in part II, second part, we need to differentiate this again, so the second derivative will be just differentiating what we had from part I. So 2x becomes 2, negative 2 will disappear because it's a constant. And so we're going to do negative 12 multiplied by negative a half, so you get positive 6. Negative a half subtract 1 is negative 3 over 2. And so that's our answer to part A. In part B, we need to verify that the curve has a stationary point at x equals 4. So let's remind ourselves. So a stationary point, that implies that dy by dx is equal to 0. So what we're going to do is we're going to sub x equals 4 into our dy by dx. So at x equals 4, dy by dx is going to equal 2 multiplied by 4, subtract 2, minus 12, 4 to the power of negative half. So we can use a calculator. 8 minus 2, 4 to the power of negative a half is 1 over the square root of 4, which is a half, times 12 is 6. We get negative 6. We get 0. So we found dy by dx is 0, so this implies stationary point at x equals 4. So in part C, we need to determine the nature of the stationary point. So we're going to use our second derivative to do that. So d2y by dx squared is equal to 2 plus 6x to the power of negative 3 over 2. So what we're going to do is we're going to sub x is 4 in here. So x equals 4. Our second derivative is equal to 2 plus 6 lots of 4 to the power of negative 3 over 2. And that's going to simplify 2. So 4 to the power of negative 3 over 2. So 4 to the power of 3 over 2. So square root of 4 cubed. So 8. This will be 1 over 8. So this makes 6 over 8, which is 3 quarters. 2 plus 3 quarters is equal to 11 over 4. And the good news is it's a calculator exam, so you can double check that. The key thing is that 11 over 4 is positive. So it's a positive number. So because the second derivative is positive at x equals 4, this implies that our stationary point is a minimum. And that's our answer to part C. In question 3, so we have a diagram. Figure 1 shows a sector AOB of a circle with center O and radius R. The angle AOB is theta radians, and the area of the sector AOB is 11 centimeters squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of R. So the formulae we need to remember here. So for a sector, the arc length is R theta, and the area is half R squared theta. That's very crucial as long as it's measured in radians, your angle, which is true in this case. So we're going to use these to create some equations and solve this question to find R. So let's make an equation with the area being 11. So this implies that half R squared theta is equal to 11. So we could times everything by 2. So R squared theta is equal to 22. So I'm going to bank that as an equation. We also know that the perimeter is 4 times the length of the arc. So the perimeter is R, and the arc length. So the perimeter would be equal to 2R plus the arc length, which is R theta. The arc length itself will be R theta. So it says the perimeter is 4 times the arc length. So we can make an equation. So 2R plus R theta must be the same as 4 multiplied by the arc length. So 4R theta. So from this, we can say that 2R is equal to 3R theta. We can actually cancel out the R's here, and we get that theta is equal to 2/3. So let's remind ourselves, so we earlier established that R squared theta is equal to 22, and we now know that theta is equal to 2/3. So that means that 2/3 of R squared is equal to 22. So if I multiply that by 3, 66 divided by 2, we get R squared is equal to 33, which implies that R as an exact value is the square root of 33. And that's the answer to question 3. Question 4. The curve with the equation y equals 2 times the natural log of 8 subtract x meets the line y equals x at the point x equals a. So first of all, we need to show that the solution a lies between 3 and 4. We then have our diagram of these two functions, and then it's asking us whether we can use that initial value x is 4 to approximate our solution using an iterative formula. When you're trying to solve two equations equal to each other, so we've got y equals 2 the natural log of 8 subtract x, and we've got y equals x. Now the way that we'd solve these simultaneously is put them equal to each other. So this would imply that x would be equal to 2 ln 8 subtract x, or the other way around. Now, to do the change of sign method, which is what we want to do to show that there's a valid solution in an interval, what we want to do is we want our equation to be equal to 0. So I'm going to take the x over, so I'll get 0 equals 2 the natural log of 8 minus x, subtract x. So now what we can do is we can sub in our values in here and show that we have a change of sign and therefore a solution. So I'm going to call f of x. I'm going to define our function here. So I'm going to sub in these values 3 and 4 from our interval. So f of 3, start with that one. That will be 2 times the natural log of 8 subtract 3 minus 3. And we put that in the calculator, we get 0.22. Now do f of 4. So we get 2 lots of the natural log of 8 subtract 4. Subtract 4, and that gives us negative 1.23. So crucially here, we have a change of sign. Now, because our equation that we created was equal to 0, if one of our values gives us positive, one of them gives us negative, somewhere in that interval it must cross. So therefore, a change of sign implies a root in the interval 4 and 3. And that's how we would show that one for 2 marks. So in part B, we need to determine whether the iteration formula they've given can be used with a starting value of 4. And they've shown us that on the graph. So the idea here is if we draw a line up from 4 to our curve, where we meet is actually the y value, is what you're kind of then putting back in. So if I go to this straight line, which is y equals x, and then if we go back from this straight line to the curve, and then back to the straight line, back to the curve, and you can see what it does, it creates this spiral that's spiraling inwards towards the solution. This is good if you're trying to use your formula to find a solution. So this means, yes, the iteration formula can be used. The cobweb diagram, that's what we call this, spirals inwards. That shows it's converging towards a solution to these two equations. And that's what we need to do for 4 marks on question 4. Question 5. Given that y equals 3 sine theta, all divided by 2 sine theta plus 2 cos theta, in the range theta is from negative pi over 4 to 3 pi over 4, show that dy by d theta is equal to a over 1 plus sine 2 theta in the same range for our theta, where a is a rational constant to be found. So we've got a function where we've got a function divided by another function, so that implies to us we're going to use the quotient rule. We've also, the thing that we're going to try and get to has a sine 2 theta in it, so we need to remind ourselves of our trig identities. So first of all, the quotient rule. So if we differentiate two functions, so u and v, where one is divided by the other, the quotient rule tells us it's v times the derivative of u, subtract u times the derivative of v, all divided by v squared. I also know that sine 2 theta, so using our double angles, so there's only one option here, it's 2 sine theta cos theta. So these are the things that are probably going to be necessary here. So when I'm using the quotient rule, what I like to do is just label what my numerator, my u, and my denominator v are. So u will be 3 sine theta, and v will be 2 sine theta plus 2 cos theta. So u dash, to differentiate 3 sine theta, you get 3 cos theta, and v dash, so you get 2 cos theta, and 2 cos theta differentiates to negative 2 sine theta. So now I can put these all in the formula. So dy by d theta is going to be equal to v multiplied by u dash, so those two, so open bracket 2 sine theta plus 2 cos theta, multiplied by 3 cos theta. Subtract u v dash, so those two times together, all divided by v squared. So we'll do a big division, 2 sine theta plus 2 cos cos theta squared. And so we're just going to need to do some simplification here. So let's start multiplying out our brackets. So dy by d theta is going to be equal to 6 sine theta cos theta plus 6 cos squared theta. Subtract 6 sine theta cos theta, so that's nice. Plus 6 sine squared theta. And then your denominator, so we just need to be careful on the bottom here. So we've got this bracket squared. So remember that if you had a plus b squared, that's a plus b multiplied by a plus b. So you've got to be careful multiplying out. So you get a squared plus ab, so plus 2ab plus b squared. So that's the idea we need to apply here. So 2 sine theta times 2 sine theta is 4 sine squared theta. 2 sine theta times 2 cos theta will be 4 sine theta cos theta, but you're going to get that twice. So it's going to be plus 8 sine theta cos theta. And then 2 cos theta multiplied by 2 cos theta is going to be plus 4 cos squared theta. So some things cancel out nicely here. So you've got 6 sine theta cos theta, subtract 6 sine theta cos theta, so that will cancel out. And then what we need to notice is also we can use our trig identities. So 6 cos squared theta plus 6 sine squared theta is just going to be 6. 4 sine squared theta plus 4 cos squared theta is going to be 4. Now if we look at our identity, sine 2 theta is 2 sine theta cos theta. If you multiplied here everything by 4, so if you'd have 4 sine 2 theta, that would be equal to 8 sine theta cos theta. So actually, we've got 4 plus 4 sine 2 theta on the bottom. Now, if we look to what it was trying to get us to show, we've got a 1 plus sine 2 theta on the bottom. So if we divide everything by 4, top and bottom, so 6 divided by 4 is 1.5, or 3 over 2. And this gets us 1 plus sine 2 theta on our denominator. So this implies then that A must be equal to 1.5. Question 6. The circle C has centre A with coordinates 7, 5. So this here, A is 7, 5. The line L with equation y equals 2x plus 1, so that line there is y equals 2x plus 1, is the tangent to C at P. Okay, so that makes sense. That's the tangent. So part A, show that the equation of the line PA is 2y plus x equals 17. So we're trying to find the line PA. And because it's through the center to the tangent, we know that's going to be right angle. So that's going to be helpful to us. In part B, we need to find an equation for C. So we need to find the equation of that circle. And then the line with equation y equals 2x plus k is also a tangent. Find the value of k. So I guess you can see that it has a gradient of 2. We're going to try and find this line that's the tangent on the other side of the circle. So we're trying to find the equation of PA. So we know it's a straight line through PA. We know it's perpendicular to L. So the gradient of L is 2. Y equals mx plus c. This is our gradient. So this implies that the gradient of the perpendicular line, so the gradient of PA, would be the negative reciprocal of 2, which is negative a half. We also know that the point 7, 5 lies on our line. So the equation to find straight lines, y subtract y1 is equal to m multiplied by x subtract x1. And so we know the gradient and we know the points that we're using. Putting all of our information into this formula, we're going to get y subtract 5 is equal to negative a half multiplied by x subtract 7. I'm going to times everything by negative 2. So that will give us negative 2y plus 10, and that cancelled out this negative half, so we get x subtract 7. So if we add that 2y, so it's over with the x, and then we add 7 to the 10, so the opposite of negative 7 is plus 7, we end up with 2y plus x is equal to 17, which is what we were trying to show for 3 marks. In part B, it wants us to find the equation for our circle. So let's remind ourselves, so the general format of a circle is x subtract a squared plus y subtract b squared is equal to r squared, and this has a center AB and a radius is r. Now we know the center, but we don't know the radius, so that's what we need to find out. So how could we find the radius? Do we actually know what P is? Do we know this point? Because if we did, then we could find the radius that way. How could we potentially find P? So we know a line that goes through P here, and we also know that PA also runs through that. So we could do simultaneous equations and we can find out what P is. So doing simultaneous equations with y equals 2x plus 1 and 2y plus x equals 17. Now because y is a subject, what we could actually do is do substitution, put that straight in there. So that implies that we get 2 lots of 2x plus 1 plus x is equal to 17. So that would be 4x plus 2 plus x equals 17. So to take the 2 over, add the x's, you get 5x is equal to 15. Some nice numbers. So x is equal to 3. And that means that if you sub x into y equals 2x plus 1, we get y equals 7. So we've just found P. P is 3, 7. So we've now found P, which is 3, 7. And we already knew A was 7, 5. So if we can find the distance between these two coordinates, we will have found our radius. And there's a couple ways to do that. So there's a distance between 2 points formula. So the distance is big square root, so the difference between your x values squared plus the difference between your y values squared. So that formula effectively comes from Pythagoras' theorem. The other way that you can do this is if we draw a little right angled triangle and we can look at the distances. So I'm going to do both methods at once and you can kind of see where the formula comes from. Using the formula, so the radius will be the square root. So the difference between the x's, so it would be 7 subtract 3 squared. Now 7 subtract 3 is the distance between the x values. So that's 4 on the bottom there. And then what we're going to do is y2, so 5 take away 7, which is negative 2 squared. Now 5 take away 7 or 7 take away 5 means that this height is 2. In this right angle triangle we've created, we can see that r is going to be the square root of 4 squared plus 2 squared. In this formula, we're going to get r is equal to the square root of 4 squared plus negative 2 squared is just the same as 2 squared. So we're going to get r is the square root of 16 plus 4, so the square root of 20, or you could say r is equal to 2 root 5. Now that we know r, and we also know the center of our circle, so we can use this formula here to find what the equation for c is. So putting this in, so our center is 7, 5, so it's going to be x subtract 7 squared plus y subtract 5 squared, and that's going to be equal to the radius squared, so it's the square root of 20 squared. So this implies that the equation for c is x subtract 7 squared plus y subtract 5 squared equals 20. In part C, it says that the line with equation 2x plus k, where k is not equal to 1, is also a tangent to our circle. Find k. So remember in part B we worked out that P is 3, 7, and we know that A is 7, 5. And we know that the tangent here is already 2x plus 1. And that's why we know that k isn't 1, because that would be the same as this one. It does mean that the tangent that we're trying to get is parallel to this one. So if we imagine what a tangent would look like parallel to that, it would have to be on the other side of the circle over here. So it's going to be a straight line that looks like this. So this is going to be our y equals 2x plus k. So I'm going to label this point that our tangent touches Q. And we've got a clever trick here, is that because we know that P to A, the center, is the radius, that journey there must be the same as that journey there. So if you remember from earlier, to go from P to A was down 2 and along 4. So we can do the same thing, go down 2 and along 4. So A is 7, 5. P was 3, 7. So Q is going to be continuing that motion. So it's going to be 11, 3, along 4 and down 2. So we can actually use the sketch to find that. We don't need to do any equations. So we now know Q. We know that the gradient of this line, M, is 2. So I'm going to use y minus y1 again equals mx minus x1. So y subtract 3 is going to be equal to 2x subtract 11. So y subtract 3 is going to be equal to 2x subtract 22. So y, our final answer, is going to be equal to 2x subtract 19. So that means here that k is equal to negative 19. That's our solution to question 6c. Question 7. Given that k belongs to the set of positive integers, so that's what that z plus means, positive integers, show that the integral of 2 divided by 3x subtract k with respect to x between the limits 3k and k is independent of k. Now what that's effectively saying is once we get our answer out, hopefully k is going to disappear. If we remind ourselves of this idea that the integral of the derivative of a function, the original function, this is where we get a natural log. So because if you differentiate the natural log of a function, because of the chain rule, you get the derivative of the original. Integrating, we get this. Now if we look at the derivative of 3x subtract k, so if you differentiate 3x subtract k, you would just get 3. Now on the top we have 2, so that means that effectively our answer can be 2/3 of the natural log of our denominator. So 3x subtract k, integrate with respect to x, is going to become 2/3, because if it was a 3 on top it would be the whole thing, the natural log of 3x subtract k. And because we've got our limits, square brackets, 3k, k. So now we're going to put our limits in and hopefully everything will cancel out. So we're going to sub 3k in there first. 2/3 the natural log of 3 times 3k subtract k. We're going to subtract 2/3 times the natural log of 3k subtract k. What are these going to simplify to? So we're going to get 2/3 of the natural log of 8k subtract 2/3 the natural log of 2k. So I could have done this earlier actually, but if I factorize out that 2/3, you've got the natural log of 8k subtract the natural log of 2k. Now our rules of logs mean that when we have a logarithm subtract a logarithm, we can actually use division here. So this is going to be 2/3 of the natural log of 8k divided by 2k. 8k divided by 2k is 4, so we get 2/3 the natural log of 4. Notice that our k has disappeared. It's gone. Our answer is independent of k. So this shows us our solution is independent of k. In question 7b, we need to show that the integral of 2 divided by 2x subtract k all squared with respect to x between the limits 2k and k is inversely proportional to k. So inversely proportional, so remind ourselves from GCSE maths, and what does inverse proportion mean? So if, for example, a was inversely proportional to k, we would say a is proportional to 1 over k. And then you could turn that into an equation by bringing in a constant. We actually normally use k, so if I use c, we could say it's c over k. Or you could say it's maybe c multiplied by 1 over k. So if we can get an answer in this sort of format, then we will have shown that. So using our rules of negative indices, we can actually rewrite our integral as the integral of 2 multiplied by 2x subtract k to the power of negative 2. So it's this rule that we've got. So say, for example, a to the power of negative 2 is 1 over a squared. And then we can integrate that using reverse chain rule. So because the function 2x subtract k is a linear function, that means that we can integrate it as if it was sort of in the form x to the power of n. So add 1 to the power, divide by the power. We just have to remember to divide by the derivative. So the derivative of 2x minus k is just 2. So we've also got to remember to divide by 2. It's called reverse chain rule because if you were differentiating, you would multiply by 2. So let's put this into practice. So what we're going to do is we're going to add 1 to the power. So you're going to get 2x subtract k to the power of negative 1. And then we're going to divide by negative 1. We're also going to divide by 2. So that's going to cancel out this 2. So we have negative 2 over 2, and these are going to cancel out, and our limits will stay the same. So let's put our limits in. So I'm going to use a big square brackets. We've got negative, and then we've got 2 multiplied by 2k, subtract k, all to the power of negative 1. And then we're going to subtract, so negative. So we're going to do 2 times k, subtract k, and that's all to the power of negative 1. So let's simplify this. So we've got 4k, subtract k, so that's 3k. 3k to the power of negative 1 will be 1 over 3k. We're going to get negative 1 over 3k. And then we're going to have 2k subtract k is k. K to the power of negative 1 is 1 over k. So we're going to get negative 1 over k, but we've got the double negative, so it's going to be plus 1 over k. So we can actually add these together, use our rules of the common denominator, add fractions. So we could say it's negative 1 over 3k plus 3 over 3k. And that gives us 2 over 3k, or if you like, 2/3 multiplied by 1 over k. So let's just write that. I'm going to call the integral I, so I can save a bit of ink. So this implies that I is proportional to 1 over k, or is inversely proportional to k. Happy day, so that's 7 marks in the bag for question 7. Question 8. The depth of water, d meters in a harbour on a particular day, is modelled by the formula d equals 5 plus 2 sine 30t, and degrees. So that's going to be important potentially. So degrees, and t is more than or equal to 0 but less than 24, and t is the number of hours after midnight. A boat enters the harbour at 6:30 a.m. and it takes 2 hours to load its cargo. So it gets there at 6:30. So it basically 8:30 a.m. That's when it would be able to leave. The boat requires the depth of water to be at least 3.8 meters before it can leave the harbour. I guess it makes sense. If it's too shallow, it would run aground. So question 8, find the depth of the water in the harbour when the boat enters the harbour. So 1 mark, so this should be fairly simple. So when it enters the harbour, what time is that? So it's 6:30 a.m. So 6:30 a.m., that means that t will be 6.5, 6.5 hours. So we're going to sub that into our formula. So d is going to be equal to 5 plus 2 sine 30 multiplied by 6.5. Make sure your calculator is in degrees mode. D is going to be equal to 4.48 meters. That's to 2 decimal places, to the nearest centimeter. That makes sense because it's above 3.8 meters, so it is deep enough for the boat to have entered. 8b, find to the nearest minute the earliest time the boat can leave the harbour. So the nearest time the boat could leave, if it was possible, would be 8:30. So I'm actually just going to double check. I mean, it says to the nearest minute, so I doubt this will be a solution. But if we just try t equals 8.5 hours, so d would be equal to 5 plus 2 sine 30 times 8.5. And so d equals 3.07 meters. And you can see that's too shallow. But that does mean then that the nearest possible time after 8.5 hours is going to be the solution that we want. So let's create an equation. We need the depth to be 3.8 meters. So if we say that 3.8 equals 5 plus 2 sine 30t, and we're going to try and rearrange this to find t. So if we subtract 5 over, we're going to get negative 1.2 is equal to 2 sine 30t. So negative 0.6 is going to be equal to sine 30t. And so 30t will be inverse sine of negative 0.6. You can also write that arc sine. So arc sine, inverse sine are the same thing. Making sure we're still in degrees mode in our calculator. So we're going to get 30t is equal to negative 36.87 degrees. So dividing that by 30, you're still going to get a negative answer. We can't go back in time before midnight. So this isn't going to be our solution. What we can do, though, is we can use this to find what our next possible solution would be. So how do we find multiple solutions for sine? So the first way, and this is how I normally do it, I remember that for the sine function, you get your first answer, your primary value from the calculator, and then you do 180, subtract that answer. So this is your first solution, this is your second. Then to both of these solutions, we add 360 degrees, or we subtract 360 degrees if we're working in degrees. That's because sine cos, they repeat themselves every 360 degrees. The other option is we could do cast. S-A-T-C. So if we use way 1, we can see that the next solution will be doing 180 subtract this answer. So 180 subtract negative 36.87 actually will mean it's positive. So we get 180 plus 36.7 will be 216.87 degrees. Using a cast diagram, what you do is you measure your angles going around here positive, and you always put a line in A, because we're dealing with sine, you put a line in S. Because it's a negative angle, we actually measure this way. So this angle would go here. Normally it would go in sine, so we go this way. So cast can be a little bit more confusing for negative angles. You then go round in circles, and you can see, so we get round, we get to here 180, and then so when we actually get to the angle is 180 plus 216, which is that same number there. So let's find t then for this one, because it is permissible, it is positive. So 216.87 divided by 30, 7.23, so that'll be 7.23 hours. So is that our solution? No, because we know that the boat couldn't leave before 8:30. So that's too early. So we then have to find the next solution. And so what we can do is we can add 360 to negative 36.87. So if we add 360 to that, we're going to get 323.13 degrees. And actually, you can see this in the cast diagram quite nicely. So if you go round, continue going round, so you go to 270 degrees, you can see it's 360, subtract that angle, you get the same thing. So t equals 323.13 divided by 30, and that gives us t equals 10.771 hours. Now the question wants it to the nearest minute. So there's a nice trick in the calculator that will turn that into the nearest minute for us. So you may have a calculator that looks a little bit like this. So let's remind ourselves of how we got our value of t. So we did inverse sine of negative 0.6, and that gave us this. And then we needed to find the third solution after this one, so we added 360 to it. And then that was our 30t, so we divided it by 30. And we got this. Now we want our answer to the nearest minute. We want it in hours and minutes, ideally in seconds. And there's this nice button here. So if you look here where it says fact, this one here, you press that button, it will turn it into hours, minutes, and seconds. So you can see here that actually, so if I press it again, so 10.771 is actually 10 hours and 46 minutes, 15.61 seconds. That's quite a useful little button, that one there. 10 hours, 46 minutes, and 15 seconds. To the nearest minute, that would be 10 hours and 46 minutes. And the logic of that, I can follow. That's the nearest minute. And the mark scheme actually would allow that. However, technically at 10 hours and 46 minutes, you would still have 15 seconds before the water was deep enough. You could argue that, it would be a very close shave, but if you left exactly at 46 minutes, you would run aground. It would only be for a few seconds. So for safety reasons, I'm actually going to go with 10 hours and 47 minutes. So the earliest time is 10:47 a.m. If you said 10:46 a.m., that's also acceptable. So we've banked those 5 marks there on that trig modelling question. Question 9. Figure 4 shows a sketch of the curve with equation x squared subtract 2xy plus 3y squared equals 50. So we have a diagram there showing a bit of an elliptical function, sort of at an angle. We've also got the y-axis labelled north and the x-axis labelled east. Part A asks us to show that dy by dx equals y subtract x, all divided by 3y subtract x. So when we're differentiating implicitly, it means that we haven't got x or y explicitly as the subject. They're all mixed up. And we just need to remember that when we differentiate it with respect to x, any function of x we do as normal, but any function of y, we just need to remember because of the chain rule, it's a function of x. So we differentiate it, but we just have to multiply it by dy by dx afterwards in practice. Now we've got negative 2xy in there, and that's two functions multiplied together. So I'm just going to remind ourselves of the product rule. So if you differentiate two functions multiplied together, it's u multiplied by the derivative of v plus v multiplied by the derivative of u. So let's start differentiating our function. So I'm just going to write out our function again. So let's differentiate this. So x squared will become 2x. And then we get our first issue, we've got this negative 2xy. So what I'm going to do is I'm going to use the product rule. We've got that written above. So I'm going to label u to be negative 2x. And I'm going to label v to be y. So u dash is going to be negative 2. And v dash, so if you differentiate y, you get dy by dx. The derivative of y with respect to x makes sense, is dy by dx. And now we can use the product rule. So it's going to be negative 2x times dy by dx. And then plus, so negative 2 times y. Now if we differentiate 3y squared, we're going to get 6y dy by dx because it's a function of y. And then the 50 on the end, if you differentiate 50, it becomes 0. So we're going to keep all the dy by dx as one side. Now I'm looking up here. We're trying to get 3y minus x on our denominator here. So I'm actually I'm going to keep the 6y dy by dx, subtract 2x dy by dx over on the left hand side, and I'm going to move over the 2y and subtract 2x to the other side. We can now factorize, so we get dy by dx multiplied by 6y subtract 2x is equal to 2y subtract 2x. We can now divide this over, so dy by dx is going to be equal to 2y subtract 2x, all divided by 6y subtract 2x. Now we've got fractions with a common factor of 2, so I can divide everything by 2, and we get y subtract x, all divided by 3y subtract x. Now if we double check, that is what we wanted. So happy days, we have completed part A. Part B, the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represents the points that are farthest west and furthest east of the origin, so you can see that in the diagram. Using part A, find the exact coordinates of P. So this point over here, P, so we're trying to find here. So we need to consider the gradient at point P. Now I think for a stationary point that's a bit more obvious. So if you're trying to find the furthest north point, which is actually what we're going to be doing part C, that's where you've got a stationary point. So here, your furthest north point, that's where dy by dx would be 0. You've got this flat line. Here the gradient, we could say, well, maybe is the gradient here, well, it's so steep, is it infinitely steep? So we can't ever put something equal to infinity, but that's almost what we're implying here. If we were going to be equating the gradient to 0, if I say I put this up here as 0, that means that eventually, effectively, I'd be making the numerator 0. So if we were going to be equating the dy by dx to infinity, the way that you would have something approaching an infinite gradient would be if the denominator was 0. So remember, you're not allowed to divide by 0, but the approach here is what we're going to do is we're going to create an equation by making the denominator of our fraction 0, because that would give us something approaching this infinitely steep gradient. So because we want to find the furthest west point P, I'm going to say that dy by dx is going to be approaching infinity. Never put equals to, because you can't be. And that will imply that 3y subtract x will have to be equal to 0. And that from that we can create this equation, 3y is equal to x. That means that we can do simultaneous equations. So we've got an equation 3y equals x, and we've also got our original equation. So I'm going to sub in x as 3y in here. So our equation is going to become 3y all squared subtract 2 times 3y multiplied by y plus 3y squared equals 50. So this is going to give us 9y squared subtract 6y squared plus 3y squared is equal to 50, which means we're going to get 6y squared equals 50, which means y squared is 50 divided by 6. And so we get y is the square root of 50 over 6, which would be the square root of 25 over 3. We've got to remember, when we use the square root to solve the equation, we need to put a plus or minus. So we could put this in the calculator, but I quite like to do it ourselves. So the square root of 25 is 5, and the square root of 3 would be root 3, plus or minus. So that means that it's 5 root 3 over 3. We rationalize it. Now, if you look at P is the negative version of this. So that means what we're going to do is we're going to take our y here to be negative 5 root 3 over 3. Our x is 3 times y. So we'd multiply that by 3, they cancel out. So what we're going to get is our point P is going to be negative 5 root 3 negative 5 root 3 over 3. In part C, we need to explain briefly how to find the coordinates of the point that's furthest north of the origin, but we don't actually need to calculate it. So the point that's furthest north will be up here, and that's a bit like a maximum point. So the key thing here is that dy by dx, the gradient, would be 0. There's also this other point down here which would also have dy by dx here at 0. So the point furthest south. So what would we do? So let's explain briefly. So the first thing I would do is I would equate dy by dx to 0. So if we did this, if we equated dy by dx to 0, what that would do is that would actually create the equation y subtract x equals 0, the numerator, and then we could say that y equals x. We would then solve y equals x simultaneously with the previous function. So we would solve simultaneous equations with y equals x and the original function. Would that be enough? Well, actually, what we would then need to do is just make sure, because there's actually 2 possible solutions, so we'd have to take the positive solutions for x and y. So that's 10 marks banked for question 9. Question 10. The height above ground, h meters, of a passenger on a roller coaster can be modelled by the differential equation dh by dt is equal to h cos 0.25t all divided by 40, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, show that h equals 5 e to the 0.1 sine 0.25t. So we've got a differential equation to solve, and we've got dh by dt, and we've got h's and t's. So this one's going to be separation of variables. And look here, they've said that it's 5 meters above the ground at the start. So this effectively is a boundary condition. It's telling us when t is 0, so the initial time, h is 5. So that's a bit of information that we can use. So let's start with solving our differential equation for pi. So when we separate these variables, what we're going to do is we're going to multiply dt over to this side. So this dt will be over with this cos 0.25t. And so to get the h over with this dh, we have to divide it over. So this was going to give us 1 over h dh is equal to cos 0.25t over 4t dt. So we've separated our variables. Once we get all the h's with the dh and all of the t's with the dt, we can add in our integral sign. We can now integrate both sides. So the integral of 1 over h with respect to h is the natural log of h. Now we're going to integrate here cos 0.25t divided by 4t. So cos integrates to sine, but because of the reverse chain rule, what we need to do is we need to divide by 0.25. So if we were differentiating, you multiply by 0.25 because of chain rule. So because it's integrating, we need to divide. So effectively, we're going to have 1 over 40, and we're going to divide that by 0.25, which is dividing it by a quarter. So that's 1 over 40 multiplied by 4 over 1. So 4 over 40 is 1 over 10. So I'm going to put 0.1 here, sine 0.25t. And remember our constant of integration. You only need to put it on one side of the equation because if you did it on both, you could cancel that out to a single constant. We can now find c using our boundary conditions. So we knew that when t equals 0, h equals 5. So let's put that all in here. So we're going to get ln of 5 is equal to 0.1 times the sine of 0. Now I'm going to be clever here. So sine of 0, so 0.25 times 0 is 0. Sine of 0 is 0. This whole thing is going to be eliminated. So we're going to end up just with c is equal to the natural log of 5. So what we're going to do is we're going to get the natural log of h is equal to 0.1 sine 0.25t plus the natural log of 5. Now let's move that over with the other natural log. Logarithms, they get lonely, they want to be together. And we end up with this. If we invert our logarithm, this will leave us with h over 5 is equal to e to the power of 0.1 sine 0.25t. And so our last step will be that h is equal to multiply the 5 over 5 e to the power of 0.1 sine 0.25t. Thus we've shown what they wanted us to for 5 marks. Question 10b asks us to state the maximum height of the passenger above the ground. So we've got this function. What we need to realize here is that this sine aspect of that, so sine of 0.25t, and it could be sine of any angle. The maximum that a sine function could be is 1, and the minimum is -1. And that means that to make your h as large as possible, so the max height, that will occur when the sine function is 1. So this will be when h is equal to 5e to the power of 0.1 times 1 effectively. And so this gives us h is equal to 5.53 meters. The passenger reaches the maximum height for the second time, capital T seconds after the start of the ride. Find the value of t. So let's remember, when we were finding that first maximum, what we were doing is we were making our sine of 0.25t equal to 1. And then what you should realize, if you draw a sketch of just a sort of a regular old sine function, so it comes up, down like this, you get your maximum value normally at pi over 2 radians. It's really crucial we're doing calculus here. We're doing a differential equation. We need to be using radians. So this means that if 0.25t is equal to pi over 2, that would give you your first solution. But we want the second one. So when does that occur? Well, that's 2 pi afterwards. So pi over 2 plus 2 pi is 2.5 pi, or 5 pi over 2. So this second maximum will occur when 0.25t is equal to 5 pi over 2. And if we times everything by 4, that's when t is equal to 10 pi. I'm going to give it to 1 decimal place. So t equals 31.4 seconds. And that's another 8 marks in the bag for question 10. Question 11. Part A. Use binomial expansions, so plural, could be important, to show that the square root of 1 plus 4x, all divided by 1 subtract x, is approximately equal to 1 plus 5 over 2x subtract 5 over 8x squared. After that, we then need to talk about why x equals a half shouldn't be used for an approximation, and then how would we actually find an approximate value for root 6 using this expansion. But let's start with part A. Our first mission in part A will be to separate this root into separate components that we can expand separately. So let's consider, 1 plus 4x divided by 1 subtract x. That's the same as root 1 plus 4x divided by root 1 subtract x. This means it's 1 plus 4x to the power of a half multiplied by 1 subtract x to the power of negative a half. This gives us two separate things we can expand using the binomial expansion formula. I'll remind you of it now. This is in the formula book, but just remind ourselves when we're expanding 1 plus x to the power of n, it's the same as 1 plus nx plus n subtract 1 over 2 factorial x squared, etc., etc. So that can be found in the formula book. So we're going to do this now. We're going to use this to expand each of these separately. So let's start with 1 plus 4x to the power of a half. So that's going to give us 1. So it always starts with 1 plus n, which is a half, times by x, but in this case it's 4x, plus n, which is a half, multiplied by n subtract 1. So a half subtract 1 is minus a half, all divided by 2 factorial, which is 2, multiplied by 4x, all squared. So it's important we put this in brackets, this 4x, common mistake there. You can use a calculator if you want to do the subtract 1 of your fractions, but I felt confident to do that. So simplify this. This is going to give us 1 plus 2x. A half times negative a half is negative a quarter. Divided by 2 is negative an eighth. Multiplied by 16x squared. 4x all squared is 16x squared. So negative an eighth times by 16 is going to give us negative 2x squared. Let's now expand 1 subtract x to the power of negative a half. So that's going to give us 1 plus n, which is negative a half, times x, which is negative x, plus n. N subtract 1, minus a half subtract 1 is minus 3 over 2, all divided by 2 factorial, which is 2, and then negative x all squared. So what's that going to simplify? So we're going to get 1 again. Negative half times negative x will be positive a half x. Negative a half multiplied by negative 3 over 2 would be positive 3 over 4. So it would be positive 3 over 8. Multiplied by negative x squared, which becomes positive. So we're going to get positive 3 over 8 x squared. And now we've expanded our separate components. So therefore our original expression, so 1 plus 4x, all divided by 1 minus x all square rooted, is going to be approximately equal to these two things we've just calculated multiplied by each other. So 1 plus 2x minus 2x squared multiplied by 1 plus a half x plus 3 over 8x squared. Now when I'm going to multiply this out, we're only going up to x squared, so we can ignore the x cubed things. So when expanding this, what I'm going to do is I'm going to layer my answer. I'll show you what I mean. So I'm going to do 1 times all of the second bracket, so you're going to get 1 plus a half x plus 3/8 x squared. I'm then going to multiply everything by 2x, but I'm going to move it along one. So 2x times 1 is plus 2x. 2x times a half x is going to be plus x squared. And then 2x times 3/8 x cubed. So I'm going to write it down. So that would be 3 over 8 times 2, so 6 over 8, 3/4 of x cubed. But actually, I don't really need the x cubed term, so I'm not actually going to worry about going past this line any further. Now I'm going to do negative 2x squared times 1, which is going to be negative 2x squared. If I do the negative 2x squared times the rest of it, I'm just going to get these things that can be higher than the powers that are required. So let's simplify these rows. So collecting this all together, we're going to see that our expansion is going to be equal to 1. A half x plus 2x will be 2.5 or 5 over 2x. And then 3/8 plus x squared subtract 2x squared. So that will be negative x squared plus 3/8 x squared. So that's going to be negative 5 over 8 x squared. Double check. Yes, that's what we were trying to show. So that's 6 marks for part A. A student substitutes x equals a half into both sides of the approximation above in an attempt to find an approximation to root 6. Give a reason why the student should not use x equals a half. So we were expanding 1 plus 4x divided by 1 subtract x, all rooted. And what we did, the technique is we expanded 1 plus 4x to the power of a half. And we did 1 subtract x to the power of negative half. Now we have a rule for binomial expansion when we've got sort of negative powers or fractional powers, is that the expansion of 1 plus x to the power of n is only valid when the modulus of x is less than 1, or you could say that x is between 1 and negative 1. This is so that your infinite power series converges. So you need small values of x so that it doesn't diverge. In our sequences, we've actually got 4x and a subtract x. So we've got to change something slightly. So we're going to say the expansion of 1 plus 4x to the power of a half is only valid for. So the difference in this one is not just the modulus of x less than 1, it's the modulus of 4x has got to be less than 1. And that implies that the modulus of x has got to be less than a quarter. You could alternatively say, for inequalities without the modulus, you could say it's got to be less than a quarter or larger than negative a quarter. So if you look at that x equals a half, x equals a half is outside this range of, say, validity. Effectively, you can't use x equals a half because the expansion is only valid for the modulus of 4x less than 1 if you're going to get an accurate approximation to that function. Part C, substitute x equals 1 over 11 or an 11th into your expansion to obtain an approximation to root 6. Give your answers a fraction in its simplest form. So first of all, let's sub 1 over 11 into the square root we have and see what happens there. So if x equals an 11th, then the square root of 1 plus 4 times an 11th, all divided by 1 subtract an 11th. So what does that simplify to? So you've got square root of 1 plus 4 11ths, so that's 15 over 11. And then 1 subtract 11th divided by 10 11ths. And so that's the same as the square root of 15 over 11 times 11 over 10. So that's the square root of 15 over 10. So that's the square root of 3 over 2. Now, if you write it like this, the square root of 3 over the square root of 2, and you rationalize it, what we end up with is root 6 over 2. Effectively, this has just shown that if we sub 11th into our root, we get an expression that's the square root of 6 over 2. It wants us to approximate root 6. So what we're going to need to do is we're going to need to multiply by 2 to get our root 6. So because the root of 1 plus 4x all divided by 1 subtract x is approximately equal to 1 plus 5 over 2x subtract 5 over 8x squared, that means then if we sub x equals 1 over 11 into our expansion, so we're going to get 1 plus 5 over 2 times 1 over 11 minus 5 over 8 times 1 over 11 squared. This should be approximately equal to root 6 over 2. So if we sub this into our calculator, this means then that as a fraction we get 1183 divided by 968, and that is approximately equal to root 6 over 2. And so therefore, if we times it all by 2, we're going to get 1183 divided by 484, just double check that, multiply that, you get 968, yes. And so that's approximately equal to root 6. As a fraction in the simplest form, we get root 6 is approximately equal to 1183 divided by 484. Question 12. The value, V pounds, of a vintage car T years after it was first valued on the 1st of January 2001 is modelled by the equation V equals A P to the power of T, where A and P are constants. Given that the value of the car was £32,000 on the 1st of January 2005 and £50,000 on the 1st of January 2012, A, find P to 4 decimal places, and II and part A show that A is approximately 24,800. We then have to interpret the constants, what they mean, and then we have to find out when it exceeds £100,000, which year for the first time. So in part A, it says that the value of the car was 32,000 on the 1st of January 2005. So if we started in 2001, this is 4 years, so T is 4 here. And then it's 50,000, 2012, so I'd say that T is 11 there. So let's make some equations and we can solve them simultaneously. So if we put V as 32,000 in, so we're going to get 32,000 would be equal to A P to the power of 4. That would be one equation. And then if we sub in 50,000, and that would be equal to A P to the power of 11. And that would be our second equation. Now we can solve these fairly easily by using division. So if I do 2 divided by 1, that will cancel out the A's and it will leave us just with P. So what would that look like? So 50,000 divided by 32,000. That would be equal to A P to the power of 11 divided by A P to the power of 4. And that's nice because the A's would cancel, and then P to the power of 11 divided by P to the power of 4, which is P to the power of 7. So this means that P to the power of 7 is this thing. So then that means then that P will be equal to the 7th root of 50,000 divided by 32,000, which is 1.5625. And so that means that P, and it wants it to 4 decimal places, will be 1.0658. We then need to show that A is approximately 24,800. So if we go back to equation 1, we now know what P is. So that means that 32,000 will be equal to A multiplied by P to the power of 4. So that's 1.0658 to the power of 4. So that means that A is going to be equal to 32,000 divided by 1.0658 to the power of 4. So that gives us A, so a bit more accuracy than we need, 24,796.8, which is approximately equal to 24,800. So we've shown what they wanted in part A. Part B, with reference to the model, interpret the value of the constant A. So we look to our model, V equals A P to the power of T. So if T was equal to 0, P to the power of 0 would just be 1, so V would just be A. So effectively A is the value of the car at T is 0. So for part I, it's the initial value of the car. Or you could say value of the car on 1st of January 2001. So part B, II, we need to interpret the value of the constant P. So P is effectively your multiplier. Each time T goes up by 1, we're multiplying by P. So what we can say is it's the factor by which P rises each year. If you remember from compound interest, GCSE, so our value of P was 1.0658. So you could see that this 0.658 is your percentage increase. So you can also say increases by 6.58% per year. This is your percentage multiplier. So that's our interpretation of the values A and P in our equation. So for part C, using the model, find the year during which the value of the car first exceeds £100,000. The equation we created was V equals 24,800 multiplied by 1.0658 to the power of t. And we want to know when this exceeds 100,000. So if we equate it to 100,000, so we're going to get 24,800 1.0658 to the power of t equals 100,000. So let's rearrange that. So 1.0658 to the power of t will be 100,000 divided by 24,800. And so we're going to have to use logarithms. So t will be equal to log, and our base is 1.0658, of this. And that's going to give us t is equal to 21.8. So because we began on the 1st of January 2001 and we want the year in which it would exceed, so it would actually happen in this 21st year. It would be towards the end of the 21st year. So after 2001, that implies the year will be 2022. For all of 2023, it will be above 100,000, but partway through year 2022, it will exceed 100,000. So that's our answer to part C. Question 13. Integrate 2x multiplied by the square root of x plus 2 with respect to x between the limits 2 and 0. And we're going to show that that's equal to 32 divided by 15 multiplied by 2 plus root 2, all in brackets there. So what technique do we need to use to integrate this? Integration by parts. So let's remind ourselves of the integration by parts formulae. The integral of uv dash is equal to uv subtract the integral of vu dash. And so what we need to do is we need to choose one of our things to be our u and one of them to be our v. So what I'm going to do is I'm going to take u to be 2x, and I'm going to take v dash to be the square root of x plus 2. So I'm going to write that as x plus 2 to the power of a half. Now effectively what we want to do is we want to fill out this grid. So if we differentiate u, we can get u dash. So the derivative of 2x is 2. And what we need to do is we need to integrate x plus 2 to the power of a half. So if we add 1 to the power, that will be 3 over 2. Divide by the power. So divide by 3 over 2 is the same as timesing by 2/3. So we're going to get 2/3 x plus 2 to the power of 3 over 2. Now from a reverse chain rule, we'd also need to divide by the derivative of the linear function that's in the bracket. But when you differentiate x plus 2, you just get 1. So that's fine for our integral. So we can now put it all into our formula. So the integral is going to become uv, so 2x multiplied by 2/3. So that's going to be 4x over 3 multiplied by x plus 2 to the power of 3 over 2. Subtract v multiplied by u dash, so 2/3 times by 2. I'm actually going to take that out the front. So 2/3 times by 2 is 4/3. And then the integral of x plus 2 to the power of 3 over 2 dx. And don't forget we've got these limits 2 and 0. So we just need to integrate the thing at the end now. So we're going to get 4x over 3. This will remain unchanged. So we're going to add 1 to the power. So that will become 5 over 2. And then we're going to divide by 5 over 2. So effectively what we need to do is 4 over 3 divided by 5 over 2. So it's going to be the same as multiplying by 2/5. So that's going to give us 8 over 15. So it's still going to have the negative here, so it's going to be subtract 8 over 15. And then we added 1 to the power, so we've got x plus 2. So it's all to the power of 5 over 2. And our limits 2 and 0. So now we just need to put our limits in there. So first of all, let's sub in 2. So we're going to get 4 times 2 over 3. And then we're going to have 2 plus 2 to the power of 3 over 2. Subtract 8 over 15. 2 plus 2 to the power of 5 over 2. So that's subbing 2 in. We're going to subtract. Now we're going to sub 0 in. Now because we've got 4x times something, well if x is 0 that's all going to disappear. But we will get something for the next thing. So we're going to get negative 8 over 15 and then 0 plus 2. So it's going to be 2 to the power of 5 over 2. And that will be what we get when we sub in our two limits. Now let's try and sort these out. So 8 over 3 multiplied by, so 2 plus 2 is 4 to the power of 3 over 2. So that's the square root of 4, which is 2 cubed. So that's multiplied by 8. And then we're going to get 8 over 15 multiplied by 4 to the power of 5 over 2. So the square root is 2 to the power of 5. So we're going to get multiply that by 32. So 2 to the power of 5 over 2, that is the same as the square root of 2 to the power of 5. So the square root of 2 squared is 2. Square that, so the power of 4 would be 4. And then got another one, so that's 4 root 2. So here, down here, we're going to get negative 8 over 15 multiplied by 4 root 2. So let's sort these fractions out. So we've got 64 over 3. 32 times a is, so 240 plus 16 is 256 over 15. And then 4 times 8 is 32, so you've got the double negative, so you've got positive 32 over 15 root 2. Do use a calculator. Combining these fractions, so if we've got a common denominator of 15, so 64 times 5 is 320. So you've got 320 over 15. Subtract 256 over 15 plus 32 over 15 root 2. So that gives us, so 320 subtract 256 is 64. So we get 64 over 15 plus 32 over 15 root 2. And that, if we factor out 32 over 15, so we'd have 2 plus root 2. And that's what we wanted to show for 7 marks. Question 14. A curve C has parametric equations x equals 3 plus 2 sine t and y equals 4 plus 2 cos 2t, where t is more than or equal to 0 but less than 2 pi. Part A asks us to show that all points on C satisfy y equals 6 subtract x subtract 3 squared. Let's remind ourselves first of some of the double angle identities for cos 2t. So we want one that involves sine t. That will be useful to us. So cos 2t can be written as 1 minus 2 sine squared t. So that's a double angle identity for cos. The reason we've chosen that one is because x has got a sine t in it, and that will allow us to combine these two. So this implies that y will be equal to 4 plus 2 lots of this. So we simplify that, we get y equals 4 plus 2 subtract 4 sine squared t, multiplying out our brackets. Y equals 6 subtract 4 sine squared t. Now if we look to the equation for x, now x is equal to 3 plus 2 sine t. So if we make 2 sine t the subject, so we get x subtract 3 is equal to 2 sine t. Now if I square everything, So x subtract 3 squared would equal 2 sine t all squared, and thus we get x subtract 3 squared would be equal to 4 sine squared t. And that is what we've got here. So this all implies then that y is equal to 6 subtract x minus 3 squared. Part B, sketch the curve C. So we need to sketch y equals 6 subtract x minus 3 squared. So what kind of curve is that? So that looks like a quadratic, and because we've got the negative in front of what would be the x squared, it's a negative quadratic. So it's going to be a parabola in this sort of shape. So it's going to have a maximum point. Now if we remember from completing the square, this idea, we can find the maximum point from this. So the maximum point will be when x is 3, so we make this thing that's all squared, we make that equal to 0, and then what we'll be left with is 6. So 3, 6 is the max point of your quadratic, so that will help us to sketch it. We also need to consider the fact that it's a parametric equation. So because t goes from 0 to 2 pi, this is a full cycle of sine and cos. So if we consider sine t will go between 1 and negative 1 in a full cycle. So if we put that into our x, so x will be equal to 3 plus, so if it's the maximum value, it will be 3 plus 2 times 1, which is 5, and x will be equal to 3 plus 2 times minus 1, which is 1. So it's important to realize here that our range of values for x is going to be between 5 and 1 when we're drawing our sketch. So when x is 1, what would y be equal to? So I'm going to use 6 minus, so we're going to put 1 in there, so 1 subtract 3 squared. So that makes 1 subtract 4, which is 2. And if I put x equals 5 in here, y will be equal to 6 minus 5 subtract 3 squared, which again is also 2. So we've got 1, 2 and 5, 2 as our sort of start and end points, and we also know the maximum is at 3, 6. So that's going to allow us to draw our sketch. So we're going to draw our set of axes. Now I'd advise you use a ruler and pencil, and then I'm going to label these points. So always label your axes. So we've got 1, 2. We've got 3, 6. And then we've got, so 3 is nicely in the middle of this 1 and 5, and then we've got 5, 2. So it's a parabola, and so the maximum's here, so we're going to get this sort of shape, something like this. So for part II, we just need to explain what we kind of already have. So as sine t is going to be between 1 and negative 1, x will therefore be between 5 and 1. We have a restricted domain, you could say. So we do not include all values for x in the set of real numbers. The line with equation x plus y equals k, where k is a constant, intersects C at 2 distinct points. So we have this equation intersects the curve at 2 points. State the range of values of k, giving your answer in set notation. So let's consider this. So x plus y is equal to k. So if we make y the subject, that's y equals negative x plus k. Now I know what negative x plus k roughly looks like. It's a straight line with a negative gradient, and it's going to go through at k. So I'm going to draw just some examples of what this might look like. So for example, if it looked like this, it's not going to cross the curve at all. There'll be no intersection points. If I drew it here, I can see here they've got one intersection point. If I draw it a little bit above there, I can see that if it goes through the bottom point here and here, I'm going to get 2 intersection points. So that's going to be crucial. So if I can get our curve to cross at this 5, 2 point, that's going to give us 2 solutions. The other option, if I go higher than it, so if I went over here, there's no solution. So I need it to be this side. So it needs to be this side of sort of just touching the curve. So I can create some inequalities with that idea. First of all, I'm going to try and see a straight line that goes through this point 5, 2. I know that y equals negative x plus k. So if I put 5, 2 in here, x equals 5, y equals 2. I'm going to sub these into this y equals negative x plus k. So we get 2 equals negative 5 plus k. So add it over, we end up with k equals 7. So if my straight line here was crossing up at k equals 7, you can see that anything above there is going to intersect twice. So from that, I can get a lower part of my inequality. I need that x has got to be larger than or equal to 7. If it does cross exactly at that point, I will get two solutions, so it can be equal to 7. For the other side of our inequality, we can apply the discriminant and our rules about the discriminant with quadratic. So we know if we get more than one solution, more than two intersections, that tells us that b squared minus 4ac is larger than 0 if you get two solutions. So we have y equals negative x plus k. And we also have y equals 6 subtract x minus 3, x subtract 3 squared. So if I solve these simultaneously, put them equal to each other, so negative x plus k, 6 subtract x minus 3 squared. Going to multiply out the brackets, we get negative x plus k to 6. So multiply out the brackets, and do it up here. So x subtract 3 squared equals x squared subtract 6 x plus 9. So we're going to get subtract x squared plus 6x subtract 9. I'm going to bring this all over to one side. We want our quadratic equal to 0, so I'm going to get positive x squared, negative x, so negative 7x, and then plus k. 6 subtract 9, so we get plus 3 equals 0. Now this equation, the discriminant should be larger than 0 for this to get two solutions. So what I like to do is just label, so my a is 1, my b is negative 7, and my c here is going to be k plus 3. So we put this all into the discriminant equation. So we're going to get, this will imply that negative 7 squared subtract 4 multiplied by k plus 3, and this should all be larger than 0. So we're going to get 49 subtract 4k subtract 12 is going to be larger than 0, and then we're going to get 37 is larger than 4k. So finally, our inequality we'll get is 37 divided by 4 is larger than k, or k is less than 37 over 4. So if we bring these two together, so we've got this and we've got this, and we need to give our answer in set notation. So our set of values for k, so it needs to be greater than or equal to 7, but less than 37 over 4. And if you imagine those straight lines with k as your y-intercept, so if it's above 7, it would meet this bottom point here, and if it was below 37.4, it would just be below where it makes a tangent, and we get those two intersections. So that's another 10 marks on question 14. So I think that's probably the trickiest question on the paper, that one. So we've just completed Edexcel Pure Paper 1 from 2018. I hope everything was clear there, but if you do have any more questions about these questions, then stick a comment in the comments and I'll get back to you and give you some more help if you need it. This is the first past paper video I've done, so there's plenty more to come. But if you enjoyed it, please do subscribe to the Hench Maths channel and like the video. Thanks for watching.